Hello, in this video tutorial I want to cover how you can import a picture into a SOLIDWORKS sketch environment and use that picture to create a 3D model of it. It is very common that you might want to work with a drawing that you can't read the dimension of it because maybe it's a very old drawing. Like in this case, I'm zooming in and out of all the dimensions in this drawing, there was only one of them that I could easily read, and that was this one. Now I really wanted to know what's the size of the shaft or what is the position of it in regards to the frame here, because I wanted to design a gearbox for it, but couldn't read the size of the shaft or all the important dimensions here. They're very bad quality. So I decided to import the picture into SOLIDWORKS, use those dimensions that I can read as reference, scale up the picture, and then create the 3D model accordingly. This gives me a very rough estimate of the sizes. It is not very accurate, but it is accurate enough, and in most cases you can rely on the dimensions that you get off this method. Depends on the project though. And also how accurate you are while following the procedure. So let me just delete this one and tell you how you can create something like this. I close this window, and first thing you need is a active sketch environment before you can import the photo into SOLIDWORKS. So I create a part document and create a sketch in one of the major planes. Then I go to tools. From there I go to sketch tools and choose sketch picture. I browse to where the picture is. You can see what kind of formats SOLIDWORKS accepts for pictures. I choose high resolution. On the left hand side you can choose the position of the picture, its angle. If you want to change the angle, you can change like so, or you can change the scale. Now there are so many settings you can change here. Obviously you can just play with them, but the most important thing is this blue line. SOLIDWORKS uses this blue line and matches the size of the blue line against a specific dimension in the picture, and scales up or down the picture to get so that that portion of the picture gets to exact dimension you enter. That's what the blue line does. But in this scenario, the picture that I imported didn't get here correctly. I assume that SOLIDWORKS has a problem with the TIF format pictures. So what I'll do first thing is deleting this one. Then I go back to the picture and create a screenshot of it. Okay, I'll open the picture. Then I go to snipping tool in Windows. And create a screenshot from the picture. Now I save it somewhere on my desktop. Don't need this, I don't need this, I don't need this. Run the same command again. Go to tools, sketch tools, sketch pictures. I go to desktop, and now it is the same picture with a PNG format. Now it is imported properly. This is the time that I'm going to use this blue line to scale up the picture. There was only one drawing that I could rely on looking at the picture, and that was this one, 10 feet and 3 inches, or 123 inches. I'm going to use that one as a reference. So what I'll do, I'm going to tell SOLIDWORKS that take a line from here to here and scale up the picture so that the size of the line is 10 feet and 3 inches. What is that line? Is this blue one here. So I drag the end of the line to this point, and the other end I drag it to the end of the dimension line. Notice that it is in vertical position just by looking at that symbol near the cursor. I make sure it is vertical and it points to the end of the dimension line in the picture. The moment I release the mouse button, SOLIDWORKS wants to know what that dimension the size of the line should be. So I just enter that 10 feet and 3 inches and press the green check mark. It scales up the picture, so that 10 inch and 3 inches in the picture is actually 10 feet and 3 inches in SOLIDWORKS environment. That's all it does. Just to confirm it, I press OK there, and then draw a line and measure the line to see if it's actually 10 inch and 3 inches. 124, 123. All right, so I measure it. It's actually exactly 10 feet and 3 inches. Not very exact, but you see there is some tolerance there. Instead of 123 inches, it's 124 inches. But for me, it is acceptable. I mean, I didn't have any dimension of this drawing, and I had to create a gearbox for it, and I needed to know what's the shaft size. So there could be some estimates, and in this project that I'm working on, it is quite acceptable. From experience, it is acceptable in most projects. So your cases might be different, but it's a very good technique to use. So to show you how it works, I come here now. I can rely on the sizes what I see on the picture. I zoom in a bit and try to draw the shaft. I'm going to revolve the shaft, so I just draw half of it in the sketch. I think it is something around, let's see what. So half of it is something around 1.8. I assume the whole shaft should be something around 3.5 inches. Then I draw another rectangle here for this pulley, another rectangle here for this one, and another rectangle here for this one. Take this shaft out a bit. Then I draw another rectangle for the whole frame, and another one for the inside of the frame. Zoom out. Looking at the side view of the drawing, I can see that there is a offset between the pulley and the frame itself. I can measure the offset too. So say if this is the width of the frame, the pulley is something around I think 9 inches. These old drawings are usually stick to the very accurate, they don't use weird numbers like 8.6789. You know, they would usually use numbers that you can easily work with. So I assume that it should be something around 9 inches or 8.5, if not 9. I stick with the 9 inches for now, and try to model the 3D model of the shaft. I exit the sketch environment, make sure that it is in the, I can see the sketches in the environment from using this drop down here. This needs to be clicked. And then now I'm going to run the revolve command. Okay, so now the contour command is set up properly the way I want it to be. And now I just press on the green check mark to accept the previews. And here I have the shaft with the pulleys in it. I wanted to create a the concrete or the frame. I use the same sketch, and here I just choose different contours like this one, and give it an offset of around 9 inches, and then I just extrude it by, say, from the mid plane. Now what I did just here is that I offset that sketch from it's a sketch plane, but extrude it from the mid plane. So what it does is that it gives me something around 9 inches offset between the frame and the shaft, just like the original drawing was. And that's all. Now I can use this 3D model to install a gearbox on the sides. That's what the client wanted, and I can rely on it for now, or I can just go to site and do the final measurements. But it's good to give me a very rough estimate of the positions of the components and their sizes. I hope you enjoyed this video, and please make sure that you subscribe and leave a comment there if you want to know more, or if you have better ways of doing this. Leave a comment there and I will definitely reply to that. Thank you so much for your time.